These steps in this lesson is basically just an overview of what we did last lesson. The basics are we take both equations and we make sure that they're in the y equals mx plus b form. We take the right side of both equations and we make them equal to one another, allowing us to solve for x. Once we have a value for x, we can take that value and plug it back into one of the other original equations and then solve for y. Once we have a value for x and y, we conclude that that is the point of intercept, and we'll just write a concluding statement. Here we're given two equations. They're already in slope y-intercept form, making it a little easier for us. We can simply write that they are equal to one another, that the right-hand side of both equations are equal to one another, and then solve for x. We gather all our x terms on one side and our numbers on the other, and end up with a value of -4 for x. Now, we can take that -4 value, plug it back into one of the equations, and solve for y. So using the first equation, we can simply say y is equal to 2 times -4 plus 4, giving us a value of -4 for y. So now we can say that our point of intercept is -4, -4. Now, many of these questions are going to ask for us to check to see if our values are the same. So we have two equations, y equals 2x plus 4. So our left side, our value of y, is -4. We plug that into the equation 2x plus 4 and check to see that our left side equals our right side, which we can readily do. Then for the other equation, y equals -x minus 8. Again, we plug in our values and check to make sure that the left side equals the right side. Our y is -4. Our right side is minus -4 minus 8, which also equals -4, thereby giving us a state of equality. And there's our graph, visually showing that our intercept is indeed -4, -4. Our next example question gives us the equations x plus y equals 17, 4x minus 2 equals -4. Now these are not written in slope y-intercept form, so we'll need to make a few adjustments to get that in correct form. So we have x plus y equals 17 and 4x minus 2y equals -4. Our x plus y equals 17 will simply become y equals -x plus 17. And our 4x minus 2y, when modified into slope y-intercept form, becomes y equals 2x plus 2. Okay, now we have two equations that are both in slope y-intercept form, and we can simply set the right-hand side of the equation equal to one another, which gives us -x plus 17 equals 2x plus 2. Solving for x gives us a value of 5. We can take that value and plug it back into one of the equations. 5 plus y equals 17, giving us a value of 12 for y, and a point of intersection of 5, 12. Once again, we can plug these values into the two equations and make sure that the left side equals the right side. For x plus y equals 17, we'll get 5 plus 12, and on the right side, which equals 17, and then on the right side, we'll get 17. Plugging these values into the other equation, 4 times 5 minus 2 times 12, gives us a value of -4, and the right side is -4. Once again, these two sides check out for equality, so we can be confident that we have the right numbers. And when graphed, we see that the lines intersect at the point 512 visually, just kind of re-emphasizing what we've already proven algebraically. Example 3. Kate is selling t-shirts to raise money for diabetes research. The supplier charges $210 design fee plus $3 per t-shirt. Kate plans to sell the t-shirts for $10 each. How many t-shirts does Kate need to sell in order to break even? Well, let's start with our declarations. C will represent the total cost for the t-shirts. N will represent the number of t-shirts. Now we're given two equations here, two sentences. The first is Kate is selling t-shirts, the supplier charges $210 design fee plus $3 per t-shirt. The 210 is a fixed cost, a fixed value that's charged even before the first t-shirt is made. The $3 is our M value. So we could write an equation that says C equals 3 times N, or $3 for each t-shirt, plus the initial setup cost of $210. And then we're told that Kate plans to sell the t-shirts for $10 each. This can be represented simply by a cost of 10 times N. Once we have the two equations, these are already in slope y equals mx plus b form. We can simply set the right side of each equation equal to one another, which gives us an equation of 3n plus 210 equals 10n. We can solve for n and get a value of 30 for n. Once we have this value, then we can take the 30 and plug it back into one of the initial equations and solve for C. So we could say cost equals 10 times 30, giving us a value of 300 for C. Now we have a point of intersection, 30, 300. If we graph these, we can confirm visually what we've already proven algebraically and see that indeed the point of intersection is 30, 300. 30 t-shirts sold for a total cost of $300 would be the break-even point. Now we can check our values by plugging them back into the equation like we have in previous slides, and we'll see that in both cases, for both equations, the left-hand side equals the right-hand side.